Imagine trying to lift a heavy bucket straight up. It's difficult. But what if I told you that by simply arranging a few wheels and a rope, you could make the same load feel much lighter? That's the amazing science of pulleys. In this video, we will understand all the pulley systems you need for the ICSE board, from a single fixed pulley to the block and tackle system, in the simplest possible way. Let's begin with the simplest pulley, the single fixed pulley. Notice something interesting. The pulley itself does not move, only the rope moves over it. Suppose the load is 100 Newton. To lift it, we also apply an effort of 100 Newton. So, effort equals to load. That means mechanical advantage equals to load upon effort, which is equal to 1. Now watch the movement. If you pull the rope down by 1 meter, the load rises by exactly 1 meter. Therefore, velocity ratio equals to distance moved by effort upon distance moved by load, which is equal to 1. And since efficiency equals to mechanical advantage upon velocity ratio, efficiency becomes 100% for an ideal pulley. But real life is different. There is friction at the axle and in the pulley bearings. Because of this, the effort required becomes slightly greater than the load. So, mechanical advantage becomes less than 1. But velocity ratio remains 1. And therefore, efficiency becomes less than 100%. Now you may ask, if there is no gain in force, then why use a fixed pulley at all? The answer is simple. A fixed pulley is used only to change the direction of effort. Instead of lifting upward, you can simply pull downward, which is much more convenient. Now let's make the pulley itself move along with the load. This is called a single movable pulley. Here, the load is supported by two parts of the rope. Each part carries equal tension. So, effort equals to load upon 2. Therefore, mechanical advantage equals to 2. If you pull the rope by 2 meters, the load rises only by 1 meter. So, velocity ratio equals to 2. Hence, efficiency is 100% for an ideal pulley. But in practice, friction, the weight of the pulley and the weight of the rope increase the effort required. So, mechanical advantage becomes less than 2. But velocity ratio remains 2 and efficiency therefore becomes less than 100%. Now suppose we combine one fixed pulley with movable pulleys. As we increase the number of movable pulleys, the effort required keeps decreasing. For an ideal system, effort equals to load upon 2 raised to the power n, where n is the number of movable pulleys. Mechanical advantage therefore equals to 2 to the power of n. And velocity ratio is also 2 raised to the power of n. And efficiency equals to 100%. Again, real systems always have friction and pulley weight. So mechanical advantage and efficiency are lower than their ideal values. The most important pulley system for the ICSE examination is the block and tackle system. Here the pulleys are arranged in 2 blocks. An upper fixed block and a lower movable block. Remember this simple rule. If the total number of pulleys is odd, the upper block has one more pulley than the lower block. For example, 5 pulleys means 3 in the upper block and 2 in the lower block. And if the total number is even, both blocks have the same number of pulleys. For example, 4 pulleys means 2 above and 2 below. Now comes the most important formula. Mechanical advantage equals to load upon effort, which is equal to N, where N is the total number of pulleys. Velocity ratio is also N. Therefore, efficiency is 100% for an ideal system. But in actual practice, mechanical advantage is less than N. Velocity ratio remains N and efficiency becomes less than 100%. Just like every other machine, a pulley is a force multiplier. It reduces the effort needed, but it never creates extra energy. Now, one final concept that students often forget. The lower block itself has weight. Let's call it W. Because of this extra weight, the effort increases. So mechanical advantage becomes N minus W upon E, which is always less than the ideal value N. But velocity ratio remains unchanged. Therefore, efficiency also decreases. This tells us something very important. The heavier the lower block, the lower the efficiency. That's why engineers always try to make the lower block as light as possible. They also reduce friction by lubricating the pulley bearings. Less friction, lighter pulleys, higher efficiency. Let's quickly revise. A fixed pulley changes the direction of effort. A movable pulley reduces the effort. A block and tackle system multiplies force using several pulleys. In every real machine, friction and pulley weight reduce mechanical advantage and efficiency, while velocity ratio remains unchanged. If you understood these concepts, the pulley chapter becomes extremely easy. In the next video, we will solve ICSE Board Numericals based on pulleys. Thank you for watching.